Hi everyone, my name is Alok Sharma and today I'll be presenting my final project for AI systems technology. It's a renewable energy trading system that automates decision making using real-time weather and machine learning. So let's continue to the problem statement. As the world is shifting towards renewable energy, manual trading has become inefficient, and these real-time decisions require accurate forecasting of energy generation, market price, and grid demand. So this project basically solves that problem. I have built a modular system with microservice that fetches weather data, and then based on that it generates ML-based forecast, and which helps in making trading decisions. And also, I have created a streamlined dashboard which helps in visualizing reports. It's all containerized and we can deploy it on the cloud. Right now, it's a local deployment, but we can deploy it on cloud. So let's move on to the system architecture which I have used for my project. Uh, okay, so I have split this architecture into 5 core services. First one is weather service, which fetches live data from weather API. Second would be a forecasting engine that predicts energy price and demand. The third is a trading service that decides whether to buy, sell, or hold the energy. Fourth one is cron scheduler, cron job that automates everything every 15 minutes, and a streamlined dashboard to visualize it. These services talk to each other using a REST API and are orchestrated using Docker Compose. So let's move on to forecast service. So basically, this is the heart of the system. The forecast service uses ML models like random forest and XGBoost, which are the package of scikit-learn. It takes temperature, wind speed, and irradiance data as input and predicts three outputs: renewable energy output, market electricity price, and grid demand. And then it saves these values with and also the timestamp in a forecast CSV, which we can later on use to visualize it. Let's move on to trading service. Trading service process each forecast rows of the CSV and makes a decision. Buy if the price is less than 35, sell if it is more than 80, otherwise hold. So it calculates the quantity based on the output and the interval and computes profit and loss. All of this is done using Fast API and runs inside a container which is exposed at port 8003 inside the dock. Let's move on to dashboard. Dashboard is built in Streamlight. It shows a forecast, trading action, market price, what is the cumulative profit, and there's a refresh button to manually update prediction, but it also updates automatically via the cron job. It is designed for real-time monitoring with clarity and interactivity. To automate everything, I created a separate cron container. It runs every 15 minutes and triggers the weather and forecast service. Trigger It triggers the forecast service and weather service via API. This way, fresh prediction and trading action are always ready, and no input user is needed. Here are some snapshots of the demo. So we see forecast plot at the bottom. You can see, and this is the forecast and trading decision, where it shows what is the predicted output at this moment of time, what is the predicted market price, and what is the predicted grid demand. And based on that, should we buy, should we sell, or should we hold the energy quantity? And what if we buy the energy, our total profit would be around that much. For example, let's say $108 in negative. So based on that, we can see for every 15 minutes, and the graph shows for market price and cumulative profit simulation. And this is the log of our cron job, which shows like it is getting called every 15 minutes. We can see that using the timestamp. It happens in the backend. Let's look into the key features. Uh, so the key features of this project is the real-time AI-powered energy trading, ML-based forecasting. It's an API-driven microservice, and we have also provided streamlined dashboards, live dashboards, and it is fully automated using a cron scheduler. All is built using Python, fast API, scikit-learn, Docker, and Streamline. In terms of benefits, if we say it's modular, so each service can evolve independently, and it's a real-time and responsive. It is a Docker portable. It is it's a portable thanks to Docker. Drawbacks would include it is relying on accurate weather data and the fact that trading logic is static. It does not yet learn from the market trends. So that is something where we can work more on it. Some of the challenges was fine tuning. So the model was trained on simulated real weather data to mimic the condition and enhance forecast accuracy. Docker container communication. So to ensure the communication is seamless, uh, we did a Docker Compose network bridge. Scheduled forecasting to for the challenge of forecasting, we did a custom cron containers, which we triggered every 15 minutes, which collected data and predicted updates. Streamline delays. So to ensure that there was no delay, each the each logic updated only when user refreshes. It does not repeatedly call the API when the dashboard is open. Conclusion to wrap up, this is a fully working trading platform based on markets microservices. It supports autonomous decision making and visualization. In the future, I plan to integrate with real grid and market APIs, replace static rules with reinforcement learning, and deploy this to AWS. I was trying to deploy this on AWS, but since T2 medium tier was required and it was not a free tier, so I had to deploy it locally and train this with a real world data set for improved accuracy. So, so let's move on to a live demo. So this is this is my project structure where I have created I have created a folder for each services like trading service, weather service, dashboards, forecasting cron jobs, environment, and the data we were storing. I'll first bring up the entire Docker system using Docker Compose. So let's run the Docker Compose build. So as you can see, it has started and the URL has been loaded on 8501. So let's open this dashboard. Just a second. So on the left sidebar, I can choose the latest forecast file. Well, it shows the latest forecast file, but if you want to see a previous forecast file, we can see from here. And the main view shows three plots: forecasted power output, market price, and trading decision. And it also shows what would be my cumulative profit simulation. And we can see the decision made for each interval. For example, around 9:43, it is asking us to hold the energy, while at 9:48 it is showing us to buy because the market price is low. So rather than generating, we can buy. and based on that, it is calculating our cumulative profit. So this is how we can, make a decision and see the reason behind it. We can also see the logs generated by a cron output. So if we go to a new bash terminal, run docker ps, we can see what kind of cron jobs are we running, and based on that, we can see the logs of them. So that's it for the visualization and the demo. Thank you.